Hello everyone. To everyone watching out there, never stop working. In the long run, your work is the only thing that is going to make you happy. So let's start from where we left off in the last video. So these are two equations that we have got after partially differentiating our loss term with respect to, this is our loss term with respect to C and with respect to M. So these are the two values that we have got, and now we have to update our M and C value. So how are we gonna update our M and C value? So M new equals to M old minus learning rate upon dr by dm. So learning rate is nothing, it's a small parameter that we give from ourselves, and it lies basically from 0.1 to 0.001 to basically 1. Okay, so basically the most of the times that I see this learning rate learning parameter, that is this value, it usually most of the time we keep it as 0.1 for the sake of our convenience. So if we write our equation again, so this is M new, this is our M old minus learning rate multiplied by partial derivative of R, that is our loss term, with respect to M. So if we consider again, like how are we gonna get our M new value? So M new would be M old, let's consider this value as 0.1, and then del R by del M we have found out here. So 2mx square plus 2xc minus 2ix. So it is 2mx square plus, I'll have to look at again, 2xc minus 2yx. Okay, so it's 2xc minus 2yx. So we will put the old values of M, C here, and x is already known to us and y is already known to us, so we will get some value here which will be multiplied by 0.1. Suppose this value we find out to be a, this value, because we know the old value of M, we know the x value because it cannot be changed. Here x is known, C is known, the earlier C value that we have got, the old value, and y is already known, the output, and x is already known. So suppose we this term got out to be a, so 0.1 a will get. So if we write it down, if we simplify it more, so it would be minus 0.1 a, where 0.1 is the learning rate and a is this value. Okay, so this way M will be updated, and in a similar way our C new will be updated by C old minus learning rate. This learning rate will be same for both the values. Okay, and then del R, that is the partial derivative of loss function with respect to C, and then also we'll get some value with some equation here, and we'll put the old values of M and C, and we'll find out our new value, and then again this value, that is y hat is equals to mx plus c, will be calculated again based on our new values of M new, C new, and this x is already known, so writing it again, more M new into x plus C new, and again the error will be calculated. Okay, error will be calculated again as y minus y hat whole square. Okay, and again we'll find some we'll find the same equation, and we'll again partially differentiate it with respect to this R with respect to M and C, and again we'll update, and we'll keep on updating m and c to the extent such that our r, that is our loss term, becomes minimum. Actually, hypothetically it is said that it should be 0. 0 is possible for when we have that one data point, but when we have several data point, okay, hypothetically 0 is not possible. 0 is not possible. In some cases it can be, in some cases it can be, but in most of the cases our loss term cannot be 0. Okay, no matter how long we run our algorithm for a number of iteration, this r value should tends to 0. Okay, it should tends to 0, like r value should be as minimum as possible, and we will run it to such extent that our value will like our this loss term becomes 0 or like tends to 0, and then we'll find at the end we'll find out the updated y hat, that will be mx plus c. Okay, so this is the weight. Okay, and this c is nothing but bias. Okay, so this y hat is nothing but mx plus c, where m is the weight, you can say, and c is the bias, you can say. Okay, let's discuss this further in our next chapter.